Hi everyone. Today we are looking at lesson 3.8 in Algebra 1, and this is explicit formulas for arithmetic sequences. Just to remind you of a couple of things. Yesterday you should have talked about, first of all, what an arithmetic sequence is. An arithmetic sequence is anything that grows by addition. Okay, so maybe make a note to yourself here that arithmetic sequences grow by addition. Okay, and technically subtraction is okay too, because you can write subtraction as like adding a negative. All right, so anytime you're adding something over and over again, you have an arithmetic sequence. Explicit formulas, which is different. Yesterday you were doing recursive formulas, but we learned the difference between these two things back in chapter 1. Explicit formulas allow you to plug in the term number and it'll spit out the term, okay? So instead of having to generate the entire sequence to find term 12 or term 50 or whatever it is you're looking for, we should be able to write a formula that will just link the term number to the term, okay? So that's our goal for today. But we're gonna start by kind of reviewing what we did yesterday. So I've got an arithmetic sequence here, and it's growing by addition, right? We're adding 4 over and over again. So the very first thing is to write a recursive formula for the sequence. So why don't you pause the video here, take a second and write that recursive formula. It should look something like this. Term 1 is 3. And then to get to the next term, we take the previous term and add 4. And just to remind you, for terminology's sake, that this 4 is what we refer to as the D value, the constant difference. Okay? So now what our goal here is to be able to come up with the 12th term of this sequence without having to be able to write out all 12 terms. Okay? And so there's some shortcuts we can take. Some of you have already started taking shortcuts. Some of your shortcuts are correct and some of them are not. But before we get there, I would like to start with something smaller. So let's say we're sitting here at term 1 and I want to get to term 3. Okay, so term 3 is here. To get from term 1 to term 3, I'm going to take 2 jumps, right? So really what I'm doing is I'm adding 4 2 times, okay? Now, that was to get to term 3. Let's say I wanted to get to term 5. Well, to get from term 1 to 5, that's going to take 1, 2, 3, 4 jumps. So I'm adding 4 times to get to term 5. So now the question is, if I wanted to get to term 12, how many 4s would I actually be adding? How many jumps would I be taking? What I'm hoping you're seeing is the relationship between the term number that you're looking for and how many jumps you're taking. You're always taking 1 fewer jumps than the term number you're trying to get to because you're starting at term 1, not term 0. So if I'm trying to get to term 12, just do this. I'm going to start at term 1, so I'm going to start at 3, and I'm going to add 4 11 times, okay? Because to get from 1 to 12, that's going to take me 11 jumps to get there. And so the really, really important thing here for us to kind of connect is that this number is my term number, so that's my n value. And notice that this number, the number of jumps, is always 1 less than that. And then also we should note that this is term 1, right? And this is that D value. So what we're going to do now is take all of those things and put them together in a formula that we can use for every sequence. By the way, answer to that would be, let's see, that's 44 plus 3, so term 12 would be 47. Okay, just in case you're wondering. All right, so we have a formula for the explicit formula. It's a formula for a formula, and I know that sounds confusing, but really it's just kind of generalizing what we did up here. To get to any term in an arithmetic sequence, I'm going to take the first term, and I'm going to add whatever that d value is, or subtract it if it's negative, n minus 1 times. Okay, and again, that comes from the fact that, like, if you're trying to get from term 1 to term 12, you're actually taking 11 jumps. Okay, so if I was going to do this for the example up above, and really I'm just going to generate, well, I'm going to have an n in it, so it won't be exactly like this, but this is what it would be if I plugged in a 12. I would say the formula for this sequence is 3 plus 4 times n minus 1. Now, if all I did was ask you for an explicit formula, this is it. You are done, okay? This is your answer. So that's an explicit formula for the sequence. But I want to draw one other connection for you, and I want you to understand why this is coming up in this chapter, which is all about linear equations. So here's what I'm going to do now. I'm going to take that formula and I'm going to simplify it. So I'm going to start by distributing the 4, and in fact, why don't you pause the video and you try to simplify it. Start by distributing the 4, and then see what you can combine. So this will give me 4n minus 4, and then I'm going to bring down the 3. Oh, sorry, that kind of got out of line there. And then if I look at these 3 pieces, I can combine the 3 with the minus 4, and so I get a sub n equals 4n, I'm going to put that first, and then 3 minus 4 is negative 1. Okay? Look at the format of that equation. Doesn't that look awfully similar to y equals 4x minus 1? These formulas are linear equations. Okay? This is 2 different ways to write the equation for this thing. And so what I really want you to pick up on here is that this slope number, the number that we would normally call our slope, that's your d value. Slope is always, because if you think about it, slope is your constant difference. Slope is your rate of change. It's what are you changing by constantly. So now the question is, where did this minus 1 come from? Okay, I don't see a minus 1 in here anywhere. If you look back at the sequence that we worked with, the negative 1 would be what we would have if we had taken 1 step backwards. So essentially, if we had subtracted 4 and gone backwards a step, this term here would have been a negative 1. That's term 0. Now, we didn't need term 0 to answer any of these questions, but I want you to understand how this relates to a linear equation. And when I simplify it down to slope-intercept form, this thing here is your 0 term. That might be helpful sometimes, because remember some of those word problems that we've done where they're not really giving us term 1, they're really giving us term 0. So we could really just jump straight to this form of the equation and not have to mess around with this up here. Okay, so the real difference is this is term 0, this is term 1. And that's exactly what this formula is designed to do. See that minus 4? That's basically taking term 1 and stepping it back to term 0. So why isn't A1 the y-intercept? Why is A0 the y-intercept? Well, from earlier in the chapter, we learned that at the y-intercept, we always know x is equal to 0. And in an explicit formula, the x is really your n value. It's really your term number, right? So this x equals 0 thing is really representing term number. And so at the y-intercept, we always know that we're looking at term 0. Okay, I know that was a lot of connections without a lot of applications. So let's try some actual examples, and hopefully that'll help that firm this up just a little bit. Oops, where are my examples here? Here we go. Okay, so consider this sequence, write an explicit formula for this sequence. Again, I'm going to pull up the formula that we copied down on the other side. So this is what I'm looking to do. A sub n equals term 1 plus d times n minus 1. And really, when I'm writing out this formula, the only things I'm filling in are a1 and d, because the an and the n are kind of like your x and y in an equation. So I would say my formula is a sub n equals term 1, which is 100, plus, okay, so my d value here is negative, right? I'm subtracting 3 over and over again. Okay, so I'm subtracting 3. And so instead of plus d, I'm going to put minus 3. And then here I'm going to leave this as n minus 1. And really, I am perfectly happy with this as an answer. We can just leave this like this. If you want to do the simplifying like we did in that last one, so you can see a more simplified version of the equation, that's okay with me, but you don't have to. So now it says find the 40th term. Well, the 40th term means that this is my n value. Okay, this is what I'm plugging in for n. So I'm going to say term 40 would be equal to 100 minus 3 times 40 minus 1. And so if you really think about, I mean, I just did this by plugging the 40 directly in for n. But what we're saying is we're starting at 100 and subtracting 3 39 times. If you think back to that first example we did, that's exactly what's happening here. Okay? This could go straight into your calculator like this, though. I would probably shorten it up and just do 100 minus 3 times 39, because I'm smart enough to be able to do 40 minus 1 in my head, right? And so are you. But if you really wanted to, you could also type this in as 40 minus 1, exactly how we had it written. Either way, it should come out to be negative 17. So term 40, the 40th term, would be negative 17. Okay, so now look at this question. Which term number is 64? So what they're doing to us now is they're giving us the term. They're saying this is a sub n, and they want to know which term number. So we're solving for n. We're trying to figure out what the n value would have to be. So it's just kind of a flip side of this. I'm plugging this in for the answer, and I'm solving for what n would have to be. And I'll go back to that original form of the equation just to make it a little less confusing, but I'm going to go, sorry, I can't decide which color pen I want to use. 64 is my a sub n. I still have 100 in as my first term, negative 3 is my d value, and then I'm going to have n minus 1 here. Now, I know I didn't make us simplify before, but probably now it's going to make sense for me to simplify. So over here on the right, I'm going to distribute the negative 3. This will give me negative 3n, and then negative 3 times negative 1 gives me a plus 3. So I'm really going to combine the 100 and the 3. So now I have 64 equals 103 minus 3n. Next up, I'm going to subtract that 103 from each side. Really, I'm just equation solving from here. So maybe pause and get a head start on me. I bet you can do it. Okay. See if you can solve for n here, but I'm going to subtract 103. Oh, and let's see, 64 minus 103 comes out to be negative 39. So I have negative 39 equals negative 3n. And then I'm dividing by negative 3, so let me rewrite here. Divide by negative 3, divide by negative 3, and we get that this is the 13th term. So if I continued this sequence for 13 terms, that last term would be 64. Okay, let's try another one. The third term in an arithmetic sequence is 53. The sixth term is 41. Write an explicit formula for this sequence. Okay. This should actually remind you of something that we did a couple of lessons ago, where we were pairing things up. We had some word problems that did this. And remember I told you up here in this formula that a sub n is like your y, that's your term, and the n is like your x, which is your term number. So what I really have here are like XY terms. I have that the third term is 53, and the sixth term is 41. So if you had to guess, what do you think the first thing we're going to do is? First thing is we're going to find a slope here. And I just want to remind you that really when I'm finding the slope in this context, I'm finding that D value. Okay? So I'm going to go, let's see, I think I might subtract, well, it doesn't really matter. I'm going to go 41 minus 53 over 6 minus 3. That's going to be a negative 12, I believe, over 3, which is negative 4. So that's my constant difference, or my slope value. Okay, I think I'm going to treat this one just like a plain old linear equation, because this is what you guys are used to. And then I'm going to just maybe switch up my terminology here. So normally we would do this, right? Y equals mx plus b. This D value, this is really the same as my M value, right? D and M are kind of interchangeable here. So my slope is negative 4, and I'm going to plug one of these points in for Y and X. So I'm going to plug in 53 for Y. M is negative 4. My X is 3 plus B. So 53 equals negative 12 plus B. And then I'm adding positive 12 to the other side, so that gives me B equals 65. Now, I just want to remind you that that B value, that y-intercept, is really your term 0. So now you have two choices. We can just write the linear equation just like we normally would, except instead of y and x, we're going to use a sub n and n. So I would say a sub n equals m, which is negative 4, n plus 65. Okay, that's probably the most direct way to do this. Okay, so again, just to remind you, the y is a sub n and the x is n. Okay, and so this is an explicit formula. This is technically a simplified version of like the one that we wrote up here. And if we really wanted to, we could work our way backwards and try to find what term 1 was, you know, to put there and then work out the rest of this. But we did all this work to find the y-intercept. We may as well just use it. Okay? Okay, so you'll want to refer back to this example as you do homework tonight for sure. Okay, so Kyra purchases a 7, and this example here, by the way, example 4, this is a problem that we did in an earlier linear equations lesson. I think the very first lesson in this chapter. I'm kind of trying to pull it full circle here because I want you to see the connection between sequences and linear equations. So write an explicit formula to represent a sequence that represents the amount of food, gosh, that's a lot of represents, but left after n days. Okay, so I know for my sequence, and I'm just jotting down the formula here again, I need term 1 plus d times n minus 1. And remember, the two things I actually care about are term 1 and d. Okay? So term 1, based on how this is written, term 1 should be after the first day. So we purchased a 75-pound bag of food. After the first day, I've already fed 0.5 pounds, okay? So my term 1 here is 75 minus 0.5, or 74.5, okay? My D value is what am I adding or subtracting consistently? In this case, I'm subtracting 0.5. So this tells me my D value is negative 0.5. So when I plug it into my formula, I'm going to say A sub n equals my term 1 of 74.5 plus my D value. Now my D value is negative, so I'm going to say minus 0.5 times n minus 1. There's my explicit formula. Okay. So now let's simplify your formula so it creates a linear equation, a y equals mx plus b equation. So this is where I'm going to jump in here and I'm going to distribute this negative 0.5. So I'm going to say a sub n equals 74.5 minus 0.5n, and then negative 0.5 times negative 1 really makes me do a plus 0.5. I'm going to put these two things together, and what I'll end up with is a sub n equals 75. Well, I guess I should write it, if I want it as a linear equation, I should put the slope part first. So negative 0.5 n plus 75. And if you look at that answer right there, that is the linear equation that we would have answered this problem with way back at the beginning of this chapter. Remember, we said, okay, this is my initial value, which is term 0. Term 0 is always your initial or your starting amount, and this is your slope because you're decreasing by 0.5. In this context, when we're talking about sequences, we say, okay, our constant difference is negative 0.5, and this is our term 0 because this is on day 0 how much food is left. But either way, this equation represents this situation. So I'm okay with your answer no matter how you format it or how you think about it. Okay, if we buy a new bag when we reach the last 5 pounds, how many days before she'll need to purchase a new bag? This is really saying, when will my term be equal to 5? Okay, when will I have 5 pounds remaining? So this is asking me to plug this in for a sub n. And when it says how many days, it's really saying what is the n value. So you could choose. You could plug it into either one of these. I think this one's already cleaned up for me, right? So I think I'd prefer to plug it in there and say 5 equals negative 0.5n plus 75. I'm going to subtract 75 from each side. Okay. And I get negative 70 equals negative 0.5n. Now I'm dividing by 0.5, or by negative 0.5, I should say. And this tends to throw people off because it's going to make your number larger, and that's okay. But 70 divided by 0.5 should be 140 because dividing by 0.5 is really the same thing as multiplying by 2. If you don't believe me, try it in a calculator. So we can try negative 70 divided by negative 0.5. And there's your 140. So I encourage you, after you finish this example, look back at the first lesson in Chapter 3, Section 3.1. You should find this exact same problem, and you'll notice that we already knew how to write these equations. Now I'm just asking it of you in a different way. But I don't care how you get there as long as you can get to the answer. Okay, hopefully that was good. We covered a lot of ground today. Hopefully that helped you out, and I will see you in class, whatever our next day together is. All right, have a great day.